Good morning to all. Welcome to today's class. I hope we are going to cover these concepts of our 6th class of vectors and as well as scalars. And there is a last lecture with the remaining in this. In this week, we have to complete the last lecture. Yes, whatever the types of vectors. In the last class, we already discussed about the vectors, whatever there here. Yeah, now already we are discussed about the first 4 vectors, whatever we are taking things here. Yes. Types of vector. Got it? Now there is a co-initial vector and coterminous vector and coplanar vector, and as well as we are completed about the non-coplanar vector and equal vectors. Up to that, we are considered here a link vector. Next, the 5th vector is the link vector or a parallel vector. Link vector or a parallel vector. This is only called what actually, yes, and here which one is called the parallel vector. All the vectors act in the same direction are called like a parallel vector. Okay, clear or not? The direction is the same. Okay, now this there is automatically they become what actually parallel vector, and as well as the link should be there here. Okay, now yes, the vector is written in the multiple of any of the number. Here we are taken one is the A bar, another one is the B bar. There is in case the same magnitude is there, the same direction they are moving. They are called what a parallel vectors only. The directions should be same. Okay, now that is called a parallel vector. May every time there is a magnitude may not the same here. There is it become also equal vector. A is equal to B. Yes, the magnitude is also different. Somewhat it is a 4 centimeter and it is also 4 centimeter. Here when it is a 4 centimeter, it is a become 2 centimeter. Yes, there is a bar is equal to be written as what here? There is a bar is equal to taken as 2 into B bar. Okay, that is automatically there is a one relation is there now. That relation is whatever there here, that is called as what actually, yes, this is called a link vector or the contain the same direction. That is called what a parallel vector. That vector is called as a parallel vector. Got it? Yeah. Next, the 6th one is what here. There is the 6th one is taken as unlike vector or anti-parallel vector. Okay, clear or not all the students? Unlike vectors, it is not a link, it is a line vector.
Temporary chat. Oh, pilani ramano. Ah.
Hey, what happened? Yeah, there is one more thing. It is what? Unlike vector or angle arc is also taken as anti-parallel vector. It is also written as what? Anti-parallel vector. It is written as anti-parallel vector. This is taken as A bar and as well as the B bar. Okay, now there is a one vector is in this direction, another vector is in this direction. Either my magnitude is the same or not, but the direction is opposite. It is called what? It is called as unlike vector. The vectors are called as what? Unlike vectors. The vectors which are contain a same direction, it is called what? A like vector. Okay, got it or not? Yes, same direction, but one is interact with another one. One is may are added with another one. That is called what? A like vectors. Got it or not? I hope you got it here. This is only about the sixth type of vectors, whatever there here. Okay, clear. Already we have completed 5 types according to the number. There is equal vectors and as well as initial vector and as well as the yes, different vectors we are considered now. There is these are the based on the parallel and as well as the anti-parallel nature. Got it or not? Yes, which is a parallel? There is a which are contain a same direction. It is called a parallel vector. Which are contain not the same direction. Opposite in the direction. It is called what? Anti-parallel vector. Got it or not? Yeah. Next component here. Yeah, there is the next component here. We consider the negative vector. Which one is called a negative vector here? There is a seventh one. Negative of a vector. Okay, which one is called a negative of a vector? Okay, now yes, which one is yes contain the same whatever the direction it will be there, it's opposite. Okay, now but it will be contain a same magnitude. Okay, now that is only called what? A negative vector of the each other. Okay, how we are considered? There is it is a A bar, and as well as there is a what? Another one is the B bar. There is a should be compulsory equal in a magnitude. Suppose it is a 4 centimeter, it also should become 4 centimeter. At that time, we written as A bar minus B bar, or B bar is equal to written as minus A bar. This is only called what? Opposite vectors. These vectors are called what? Opposite vectors. Got it or not? Yes, and this is the negative of a vector. This is the what actually? This is not called a negative vector. Unlike vectors, when the unlike vector is a contain a same magnitude, okay, now that become what? Negative vectors. Okay, clear or not? When there is a like vectors are contain the same magnitude, it is a called what? It is a called what? It is a called as. It is called as. Okay, now it is a called as equal vectors. It is called as equal vectors. Got it or not? Yeah. Next it is the like one. Unit vector. Yes, this is the called what? Actually, next component is a unit vector. Got it or not? Next component is written as a unit vector. Which one is called as a unit vector? Which are contain the magnitude is a unit. Okay, now clear or not? Magnitude is a unit. That vector is called what? Unit vector. Got it or not? Yes. How we written that is, you have to take a vector and it is a multiplied by its a magnitude, whatever maybe it is. Okay, clear or not? At that time, we'll get the what? A unit vector. I hope you got it here. There is a what? A bar is a yes, a vector. It's a unit vector may denoted by a cap. Okay, now read as a cap it is. Okay, clear or not? Yes. Now there is a bar is a one of the vector. the vector unit vector is a become what actually we written as a cap. The a cap is equal to written as a bar by mod a. Okay, now a bar is actually vector. Mod a is nothing but what actually it is a scalar of that vector, or otherwise the magnitude of that vector. That is only called a unit vector. Got it or not? I want to give the example for the unit vector. Yes, please note down up to here. Note on it. All the different types of vectors are there. Okay, now the diagrams are important. You have to note down it. Got it? There is a any time of the vectors is a contain the same direction. Suppose the question is a given slide for you. The both the vectors are moving in a same north direction. They are become what actually parallel vectors only along the north direction. They become parallel vectors. Okay, suppose one vector is along the east, another vector is along the north. That is become okay now. Yes, not a parallel vector. But anti-parallel is nothing but exactly when we are taken on north and as well as the south. Okay, now one vector is along the north direction, another vector is along the south direction. Okay, automatically they become the what? Anti-parallel vectors. Got it? This is only about the yes, parallel, anti-parallel, unlike. There is a negative vectors are nothing but should the magnitude should same here. Okay, but our directions are opposite. Okay, now once check it. The magnitude of this vector is a 4 centimeters only. It is also 4 centimeters only. Okay, now clear or not? And just we are deep. There is a what we are taken. Directions are different. This is in a what actually east direction. This is in a yes west direction we are taking. That's why they become anti-parallel vector. Now there is a unit vector. Means what we are taken here. A bar is one of the vector. This vector is divided by somewhat magnitude of it. Suppose okay, now any vector I am taken like this here. Unit vector means what you know. There is a when we consider one vector. Actually, there is a vectors are considered in this form. A bar is equal to taken as 4i plus what it is 4j and 4k. Somewhat I am taken like this here. What is this ijk? We'll discuss later about. Okay, clear or not? These ijk are the unit vectors along the x-axis, y-axis, and as well as the z-axis. They indicate the direction. How we consider the unit vector of it? A cap is a become what actually? Yeah, it is a divide by the yes like this. What it is? Divide by the 4 now. Okay, clear or not? Now it become what? It become is I plus j plus k. Okay, clear or not? Now the unit vector of the vector as 4i plus 4j plus 4k. This is only the unit vector. Understood or not understood? Yes, this is what actually a bar by 4 simply. Okay, now what is the magnitude of it? 4 na. That is only we are considering. Got it? The magnitude is a different here. Yes, I am taking just example for you. Simply you take magnitude is another formula is there for the magnitude. A bar nothing but a xi plus a yj plus a zk. Okay, now in the three directions you are taking, the magnitude is a become ax plus ay az s squares we are taking. This is only become the magnitude of that particular thing. That magnitude is a made okay in a division. You'll get the what unit vector for it. Okay, got it? A bar by mod a is only give the what yes unit vector for us. Okay, clear or not? Yes, and suppose simply there is a magnitude of the one vector is a 4. Okay, na? And then the vector unit vector is a become what? Yeah, whatever the vector may be a bar. the magnitude of that vector is a become 4. They given like that. Then the unit vector is a become what? A bar by 4 simply. Understood all of you? Divide by the magnitude, the number magnitude, whatever they given for it. In case the magnitude is not given, you use this formula. Okay, you may get not now in a 7th class you get it. Okay, what is this actually? Okay, now as all the students understood or not, A bar is nothing but A cap. A cap is also one of the vector only, but it is indicate the unit vector. How will you get that unit vector? You'll get that unit vector when we take a mod here. Okay, clear or not? Mod is nothing but, yes, modulus is nothing but magnitude of the vector. Got it or not? Yeah. Next, after this, we are going with the what next ninth one. Zero vector. Okay, clear or not, all the students? Zero vector. Which one is called a zero vector here? Yes, the vector, the resultant of the two vectors is equal in a magnitude, but opposite in a direction called a null vector or a zero vector. Okay, yes, there is a zero bar. It is represented by the zero bar. And initial point and terminal point of the null vector is a coincide. So the direction of null vector is indeterminate. Okay, clear or not? This is a very important. There is a what? When we are taken a two vectors here, A bar, another one is also A bar, but it is opposite to this. Okay, clear or not? Yes, the resultant is a become what? A zero bar. Yes, clear or not? This is only called what? A null vector. Or otherwise, there is a one vector, it is a bar, another vector, it is a B bar, opposite is these things. But they are equal in one another. Okay, clear or not? Now the resultant of these vector is a become what? Tell me, A bar plus B bar is equal to taken as, actually here A bar is equal to what? Minus B bar. A bar is equal to minus B bar, but both are equal but opposite in the direction. When we are taken here like this, it is also written as like this or not? A bar is equal to also written as what? Minus B bar, or B bar is equal to also written as I am minus A bar. Written or not it is? One is opposite to the other one. Yes, that is why automatically the A bar plus B bar is equal to become what? A bar minus B bar. Both are equal or not the vector? That is become what? A zero bar it is. Okay, but there is no vector, it is not a correct. There is a vector is there. Okay, but that is a what? Null vector. Means what? It's a starting point and ending point are a coincide. Okay, na? Actually, the starting point and ending point may not a coincide for the vectors everyone. Okay, na? Same direction but opposite. Okay, suppose I am taking here like this. There is a one. It is a one of the vector. The terminal vector of it will become what actually? Like this. Got it or not? This is the initial vector. The terminal vector we are taken for this particular position only. Okay, now yes. And here where I am taken the terminal vector? Yes, from here. Got it or not? Understood or not? There it is a one point. This point is a what actually one of the vector. It is indicate the initial vector. What is the terminal vector? This particular point. Yes, there is a terminal vector for nothing but the direction is coming towards the point. Okay, now the resultant of these two things are become what? Zero. That is only called what actually? That is called a null vector. The terminal vectors and as well as the yes initial vectors points, starting points are coincide here. Okay, now the terminal points and initial points of the two vectors are coincide. The resultant is a become what? Null. Okay, the resultant become is what? Null vectors. Okay, clear or not? And here, yes, there is a given here. The velocity of a body projected vertically up at the highest point. The velocity of the bob of a simple pendulum at a extreme position. Okay, clear or not? Yes, one body is projected here in this particular position. Okay, one shake it, the velocity, it will become what actually? The velocity, it will become yes, when it is projected here. When it again comes from this point to here, freely fall. It's a start from where? Okay, this top piece is a Okay, now it will be what actually it will be reaches to here. Okay, again it will be start. It's a start falling. It is from where? Here only or now? Yes, it will become what? When it will be moved towards in this direction, it is the initial vector. The terminal vector is nothing but yes, like this here. Okay, clear or not? Yes, along the same direction or not? Okay, it is an opposite direction. No, the same. Okay, same path. Here it will be moves and it will be comes. Okay, the same direction only it will be comes. But when it will be projected, it will be move in this direction. When it will be yes fall, it will be in this direction. You got it or not? Yes. Otherwise, when you take a pendulum, okay, it will be moves like this now. Yes. When it will be moved to the extreme position, pendulum is nothing but like a swing, uyala. When you are moved to the extreme position, you are moved to the particular direction. Okay, now where you are again, you have to come down here. You start from where? From that extreme position or not? You are moved to here, and as well as you are coming in this direction. We want to give a directions or a combination of the two vectors when you are moved to the extreme position to again there is a mean position. Yes, that will become what actually? That will become what actually? That is a become null vector. Got it or not? Yeah, I hope you understood. We want to take here there is a pendulum. What happened? It is a called extreme position. Got it or not? When it is a reaches to here, again it will be comes to the main position in which direction? In this direction or not? Okay, it will be reaches to here. This is the called a swing. The person is sitting here. Yes, you are pushing that particular person. He moves towards here, and you want to stay here only. No, again it will be comes here only. But he comes toward this point. He moves from this point. The resultant is a become what? Yes, null. Okay, clear. This is only called a null vector. Okay. Yes. Yes, this is the ninth component, null vector. And next one is the 10th one. What is the 10th one? Properties of zero vectors here. Properties of zero vectors. When there is a null vector is there, and what is that properties we are considered here? Before going to the 10th point, there is a we are going with the what properties of vector. Yes, properties of null vector. When we are added as null vector with any vector, we get the same vector only. Okay, a plus 0 become what? A only. Okay, clear or not? A plus 0 become what? A bar only. A bar plus Z bar is 0 bar is become A bar. When we add the null vector to any vector, we'll get the same vector only. Okay, clear or not? And A bar minus B bar is equal to null vector. Then A is equal to become what? B. A is equal to become minus B bar. Okay, now and one more property is also there. A bar minus A bar, it is equal to 0. These both are called what? Equal vectors. Okay, A bar minus B bar is become what? Equal vectors. Got it or not? Yes. Next, when we are multiplied, yes, with the any number. Okay, clear. That vector is a become what? A null vector only. Okay, clear or not? Any number, suppose a 4 into O bar, it will become what? 0, not a 4. Okay, now generally multiplication purpose. Understood or not? Yeah. When you get the problems, this may I understood for you. Yes, when you take a bar is equal to. Okay, suppose I am taken A bar is one of the vector. Okay, now please note down this all. A bar is one of the vector that is represented by as a what actually A1I plus what A2J bar it is. Now A bar plus O bar is equal to become what? A1I plus A2J, okay na, 0 bar, okay na, plus 0 bar, it is again gives as a what? A1I plus A2J only. Got it or not? This is the become what actually? A bar only or not? What we written A bar? A1I plus A2J bar. Okay, it is the 0 bar. Means what? 0 into I bar plus 0 into J bar. A1 plus 0, A2 plus 0. Okay, that is become what? A1 only. Okay, clear or not? In this way, we have considered that all properties. Okay, suppose n into O bar, then giving what actually? O bar only. Okay, clear or not? N into O bar is a become, yes, O bar only. Have you written it is? There is a what? N is nothing but somewhat 4 into O bar. That is become what? O bar. Means what? 0 bar. Okay, null bar it is. Okay, clear? This is only we are consider for the properties. We have different properties. Once look at the textbook. Yes, A bar plus O bar is equal to A bar. A bar minus A bar is equal to 0 bar. Okay, now how we written A bar minus A bar here? Yes, A bar minus A bar, how we written here? A bar minus A bar. How we written here? There is a A is equal to taken as A1I plus A2J minus A1I plus A2J only. Now it is written as A1 minus A1I bar. Okay, please sir. And A2 minus A2J bar. A1 minus A1. It is become 0 bar. Okay, na 0 I bar and plus 0 J bar. Okay, clear. Now it become called what? 0 bar. Understood all those? Yeah, these are the properties actually. Okay, na properties. The 10th component. That's it. Okay, na 10th component. Properties. It is the 10th one only. The 10th component. It is a one property. It is a second property. Like that, it is a third property. Proofs of that properties. Okay, na are very important. These. Yeah. Next, axial vectors. The vectors acting along x comma y or a z axis. Okay, na that is called a which vector actually. Okay, clear or not all those? The vectors acting along x comma y or a z axis. The vectors parallel to the any one of the axes are called axial vector. That is called a one-dimensional vector. Okay, clear or not all? Yes. Actually, the vectors are acting along the any particular vectors and parallel to any one of the axes are called axial vectors. Okay, there is very well. There is a three axes are there. Okay, now yes, and actually there is a z axis, x axis, y axis. Z axis is a looks board towards the board, inside of the board, and towards the board like that. Okay, but it is not possible to write like that. That is why I am right here in this mode. X-axis is nothing, but Z-axis looks like this. Okay, clear or not? Like this. X-axis is in this direction, Y-axis is like this, X-axis is like this actually. Yes, there is a this manner. Okay, clear or not, all the students? Suppose it is a what actually? It is a X-axis, it is a Y-axis. There is my thumb is indicate the what? Yes, Z-axis. Got it? Or in this particular direction, there is axes are there. Any axis is or any vector is a parallel to the vectors. Parallel to the any vector, any our coordinate axis, x-axis. Okay, now this is called axial vector. Understood all of you? There is what we have to write. Suppose x and y-axis only. In case the vector is a parallel to the y-axis, it will be not a made angle with the axis. It is a called what? A parallel vector. It is a what? A parallel vector. Along the not. You are not take along the vector. Okay, clear or not? But a parallel to the vector. Suppose it is a parallel vector to the x-axis. That's why it is called axial vector of x-axis. Okay, parallel to the any coordinate axis like x-axis or y-axis or a z-axis. That is called axial vector. Understood all of you? Yes. Now there is a this vector. Suppose I am written A to the B. The AB is the axial vector of y-axis. Okay, now I am right. There is a vector like this. Here there is a C and angle of the D. The vector is axial vector along the x dash axis. Got it or not? This is only about axial vectors. Okay. Yeah. This is a one more type of vector. And it is also called a one-dimensional vector. It is a contain only one component. Means what? It's written like that one. Xi bar or yj bar or szk bar. Like that only may possible to write. Got it or not? Yes. Next one is two-dimensional vector, or otherwise it is also written as a plane vector. Yes, two-dimensional vector, 2D vector. Okay, means what? It belongs to the two axes, x and as well as the y. Okay, clear or not? Yes, like this. This is not a parallel to the any axis. It will be in the plane. Okay, now. Yes, and it will be written as like this: xi plus yj. Okay, clear or not? Or otherwise minus xi plus yj. Why? Because it is the x dash y plane. It is the xy plane. Okay, clear or not? Yes, and in case I am right here like this also. Yes, there is a what it will be written as xi minus yj. This is the belongs to the xy dash plane. Okay, in case I am right like this, xi minus yj minus xi minus yj bar. This is in case the vector is here. It is a called what? It is a called x dash y dash plane. There is a when it is a belongings to the plane, not along for a axis only. Okay, now not we consider only axis, only not a container one term. That it will be contain a two terms. Okay, now that is the called what? That is the called as 2D vector. Okay, clear or not? 2D vector or two-dimensional vector. Got it or not? It is called a two-dimensional vector. Next, 13th one, space vector. Space vector. Which one is called a space vector? If any vector possesses components along all the three axes x, y and z, such vectors are called space vectors. Got it or not? I hope you got it here. There is what we are considered. Any vector it is there. The vector is contain what actually the vector is a contain, yes, in a components along the all the three axes, it is called a what? A space vector. Means what? When I am taken the vector, there is along the all axes. This is the z axis, this is the x axis, this is the y axis. In case I am right, there is any vector like this AB, it is going through the all the axes. At that time, that looks like in a which manner? Xi plus yj plus zk bar. Okay, clear or not? The AB bar is equal to written as the components along the all the axes. Along the x-axis, the component is there. Along the y-axis, the component is there. Along the z-axis also, there is a component is there. Suppose you are sitting in the room. Okay, now you are sitting in the room. It will be indicated by the vector. It is a required compulsory space vector only. Okay, clear or not? Why? Because our room is a three-dimensional thing. Okay, right? It is a contain of what? X-axis, y-axis, and z-axis. Okay, how? Then it will be floor. It is looking like a one axis. Height. Okay, another axis. There is a width. There is another axis. Got it or not? Length, breadth, and as well as the height. Okay, now it will be looks like a box or not? The box is a contain length and as well as the breadth and as well as the height. The combination of these all is a become called a space. Okay, yes, the combination is called become as a space, and here we want to give the position for you. We have to give related to the x-axis your position. We have to give related to the y-axis your position. We have to give the related to the z-axis to your position, and as well as we require directions also. At that time, there is a what that is a called actually that is a called as a yes space vector. Otherwise, suppose I am taken on the board this point here. The board contains only two axes. What is that? This is only the length and as well as the height. Here are other width. Okay, there is it is a called two-dimensional. Okay, clear or not? That is why it is a called 2D vector. Got it or? Yes, and a single nothing but you are traveling along the one rope, on one rope in air. Okay, clear or not? A rope is nothing but only an axis on the point here we can see. Got it or? Yes, above these things you'll get later clear information, but you have to note down there is a 2D vector nothing but two components. One is along x-axis, another along the y-axis. Okay, now there is a no components are there along the two axes. It is a called a one axial vector. Okay, clear or not? Or a one-dimensional vector. Or it will contain a three components. It is a called a what a space vector. Okay, clear or not? This is only the different types of the vectors are there. And tomorrow I'll go with the what is the angle between vector and Cartesian coordinates, what orthogonal vector is what, orthogonal unit vector is a what. Okay, and as well as important things, practice sheet also we are going to discuss. Don't miss it. Okay, now thank you. Bye, take care. Any doubts, students, for you? Any type of vector is a doubt? We are taking a lot of the things today. Okay, now like unlike there is a unit and as well as the null and as well as the axial s and as well as the space and as well as the two-dimensional, like these all components we are discussing.